Hello, in this problem we will see the Poisson distribution. Now this is a common IB question, basic one, so as to understand also the Poisson distribution, how it works and how you will solve the problems. Let's see it. It says George goes fishing. From experience he knows that the mean number of fish, I will point out some basic things in the question. The mean number of fish he catches per hour is 1.1. It is assumed that the number of fish he catches can be modeled by Poisson distribution. Obviously, I must use the Poisson distribution. On a day in which George spends 8 hours fishing, 8 hours, find the probability that he will catch more than 9 fish. Now obviously this is a Poisson distribution. I can immediately say that, listen, my variable x follows Poisson distribution with, we always say that I have a variable follows Poisson distribution with a specific mean. That mean is also denoted as lambda. Lambda is the mean. So basically I can write the Poisson follows lambda, the mean. These are letters that I can use as a mean. Now here they ask me, they tell me that, listen, the mean number of fishes that he catches per hour is 1.1. But the interval that I'm interested in, it's 8 hours. One day George spends 8 hours. So basically the mean time for these 8 hours is 8 times 1.1, it's 8.8. So basically my variable follows the Poisson distribution with lambda mean 8.8. Now in many problems this is the most defining factor. They will give me a mean number in a specific interval, time period, 1.1 here. How much is the mean per hour? But they will ask me in hours. If it would be 24 hours here, the mean would be 24.24. 24 times 1.1. So be careful. Every time I have to combine these two things. Now I will go to calculate what's the probability that he will catch more than 9 fish. Now if I will write that as a probability, obviously I want the probability of x being more than 9. Now the problem is my calculator. Some calculators can calculate immediately that, but TI-84 cannot calculate. This is a cumulative probability because I want more than 9, which means 10, 11, 12 and so on. I don't know where up to goes. So in my TI-84 calculator I cannot calculate how much is to catch more than 9. More than 9, basically it means that I want to calculate that he will catch more than 10 and more. 9 is not included. So how I will calculate that to find the probability that he will catch 10 and more, or more than 9? Now this is always the same thing. In my TI is like I calculate 1 minus that the probability that he will catch less or equal than 9 and below. So I must calculate how much is that probability and I will withdraw it from 1. If I will put it in a graph somehow, let's say this is the probability that he will catch 1, 2, 3, and so on. Now I want the probability that he will catch more than 9. More than 9, it means 10 and more, but also 10. So what I will do with my TI, I will calculate how many he will catch up to 9. Don't forget, Poisson distribution is a discrete distribution. That's why I have these cases here. Now, what I will do, I will bring my calculator here. I have my mean. So now, I will calculate my probability. So I will press second distribution. I will go to Poisson, but I will go Poisson cumulative frequency here. Me, which is the mean, the lambda, 8.8. My x value is I want up to 9, basically, and that's 0.6137. So here it's gonna be the value, it's gonna be 1 minus 0.6137 and so on, 39, whatever, which is equal, let me see, I will make 1 minus that value, the previous one, 0.3862 and so on.